Hello, everybody. This is going to be a quick demo on how to build the Transcontinental Railroad. And again, we're going to do it in 6 years instead of 12, just like they did in the 1860s. This is going to be the mutable edition where you have a mutable railroad. And we're going to use void fork because the tasks that we create don't return a value. And again, just like they were facing before, you want to build a railroad from Omaha to Sacramento. Rather than doing it in 12 years, let's hire 2 companies to each do one side in 6. We will, if it's the sequential program, which would take 12 years, would do it this way: build one half, build the second half, and then you can take a train. What we want to do is do it in 6. So we're going to create a fork in the road and have each half built in parallel. We'll join up in Promontory Point, and you can build this with fork, or you can use void fork because we're going to use the mutable edition this time, which doesn't return values from things. So you recall from last time, we had this sequential railroad construction, and we built a parallel version, which was returning new railroads, right? And we were joining those railroads together. They were immutable. Everybody returned a value. It had this nice thing of a return of a future railroad. Now you can imagine that mutable railroad is sort of encapsulating a lot of these details about Sacramento and Omaha, and it's just gonna provide some methods for us, like build the Union Pacific, build the Central Pacific, and take the train from the beginning to end. So it's nice and clean. We're feeling good about starting with this. And so let's just start to build our parallel program. So I've copied that. And again, we're gonna do something in parallel. So we can build it with fork. There's nothing wrong with that. I'm gonna build a fork a task here. And I'm just going to copy in building the Union Pacific. Now it's complaining because fork expects you to return a value. And so I could return just null. I can return anything I want here. We're not using it. I could return Fred if I wanted. But it seems like null is a good value because that's nothing. And so now I can run this program. And now this will happen in parallel with this guy. I tragically have forgotten to join here. It's going to be a problem. It's one of the things that if you don't need a value from this, you can very easily forget to do this. But if I run this program right now, it will fail sometimes because I've created this data race. Like I made this mutable railroad. This guy right here is building the Union Pacific. I simulate about 6 years by just sleeping some amount between 550 and 650 milliseconds. And then I'm going to set this value. I'm going to set the start city of the Union Pacific to be Omaha, or an optional of Omaha. And then down here in this part where, where I take train from beginning to end, I'm reading those values, right, in a different task, right? And so what has happened here in this program is that I have done this mistake where I forgot to join, right? And so this guy is writing to data, and this guy is reading from it, right? And we have 2 tasks, both of which are accessing the same data, and at least one of them is a write. So that's a data race, and it makes it so that it'll play out differently the different ways you go. And so mutable data is a little dangerous, right? You have to be careful that you do the right thing. Now, whether or not you use fork, which returns a null, or the void fork function, you sort of faced with this, or the void fork method, you're faced with the same problem, right? This is going to have the same data race because the same situation. This task is mutating data and this task is reading it, and there isn't a join in the middle. Now, when I pass join, I need some future to pass it to it, right? And so again, you can make a future. This time, they're always a void because void forks by definition don't return anything. And so now we're just using this future not to get a value out of it. We could ask this value like void v equals it, right? That would be correct, but no one cares about it because it's always null. And so now when I run it, we've gotten rid of the data race, right? I still have this mutable data, but no 2 tasks are mutating the same part of the data. This build Union Pacific is running in parallel with build Central Pacific, but they're both mutating different pieces of data. And when we come down here and we start reading from them, right, in parallel, the join has made sure they both completed. So now we have, again, the nice version of the computation graph where Everything's, we have mutable data, but we don't have a data race. Everything will always turn out well, and everyone will be happy in the end. And so that's how to build the Transcontinental Railroad with both void fork and mutable data. And there'll be times in which we need to, there's times when, you know, you have mutable data lying around and you need to use it. You just have to be more careful. So it's not like you should never do void fork or anything like that. We're going to use it in this class. You just have to be a little bit more careful when you do it.